Let us solve a question on output elasticities. The question is, consider the production function is Q is a function of capital N labor which is equal to 2 under root K plus 3 under root L whole square, where Q is the output, K is the capital, L is the labor. If N subscript K and N subscript L denote output elasticities with respect to capital N labor respectively, then the value of N subscript K plus N subscript L is, options are being given, we need to find out the correct option. Okay, so given this production function, if I rewrite it as Q is equal to twice under root K plus 3 under root L whole square, then output elasticity of labor, rather output elasticity of capital is being given by, that is the change in the output due to change in the capital into capital upon output. Simple function, simple logic, like the way in which we compute the price elasticity of demand, in the same fashion we compute the output elasticity of capital here. That is the change in output due to change in the capital times capital upon output. Okay, so first we need to find out this very derivative, that is del Q upon del K. That means the derivative of this function with respect to K. So first we apply the power function rule, 2 becomes coefficient, so we have 2 times 2 under root K plus 3 under root L. Okay, then we multiply it using the chain rule, and internally we differentiate with respect to K again, that is d upon dk of this 2 under root K. Okay, 2 under root K. So what we will be left with, so we have twice 2 under root K plus 3 under root L. What is the derivative of d upon dk? D upon dk of 2 under root K, it can be written as K raised power 1 upon 2. Its derivative will be, so exponent becomes coefficient, so we have 1 upon 2 into 2, K raised power exponent is subtracted by 1, 2 gets cancelled, we are left with K raised power minus 1 upon 2. Okay, and it can be written as 1 upon K under root K. Okay, if I transpose it to the denominator, so here we will get 1 upon under root K. Okay, so let me rub this out now. Then output elasticity of capital will be equal to, so output elasticity of capital will be equal to this derivative which we calculated it as twice 2 under root K plus 3 under root L divided by under root K into K, we have here K, divided by Q. What is Q? Q is this function 2 under root K plus 3 under root L whole square. Okay, now here this and this will get cancelled. One one term, here we have square, here we have only 1 as the exponent. Okay, that means what will we get? So we will get N subscript K will be equal to, if I rewrite it here, you can see we are left with twice K, transposing this to what we call numerator, it will become K raised power minus 1 upon 2. Okay, and in the denominator we are left with 2 under root K plus 3 under root L only. Okay, so bases are same, we can add the exponents, we will get 2 K raised power 1 upon 2, because 1 minus 1 upon 2 is 1 upon 2, divided by 2 under root K plus 3 under root L. Okay, so we have 2 K raised power, so it can be written now in this fashion. Let us write it in the under root fashion. So we have 2 under root K divided by 2 under root K plus 3 under root L. Okay, this is our output elasticity of capital. So let me rub this out. I forgot to mention about the output elasticity of labor that we have to find out. So this is our output elasticity of capital. Similarly, we need to find out the output elasticity of labor, and let us write it here. So output elasticity of labor will be the partial derivative of production function with respect to labor times labor upon output. Same logic here, we need to find out del Q upon del L first. Okay, so partial derivative of this function with respect to L using the power function rule first. So 2 becomes coefficient 2 under root K plus 3 under root L, and exponent is subtracted by 1, so our exponent is 1. Then we take the derivative with respect to L of 3 under root L. So del Q upon del L will be equal to, so here we have twice 2 under root K plus 3 under root L, the derivative of this function, okay, with respect to L. So we can write it in this fashion: 3 L raised power 1 upon 2. Its derivative will be 1 upon 2 will become coefficient, so we will have 1 upon 2 into 3 L raised power, and exponent is subtracted by 1. 1 upon 2 minus 1 is minus 1 upon 2, and this can be written as 3 upon 2. Transposing this to the denominator, it will become plus 1 upon 2, which can be written as 2 under root rather let's write it in this fashion: L raised power 1 upon 2. Okay, so in this place I can write 3 upon 2, then I have L raised power 1 upon 2. Okay, so let me rub this out. Here 2 and 2 will get cancelled. Then what will be the output elasticity of labor? Output elasticity of labor will be equal to this dq upon dl, which we got here 3, we have here 3, then we have 2 under root K plus 3 under root L divided by this L raised power 1 upon 2 into L. Okay, L divided by Q. Q is this function 2 under root K plus 3 under root L square. Okay, here one term will get cancelled, so we will be, and transposing this to numerator, we will get n subscript L will be equal to, so L into L raised power minus 1 upon 2, when we transpose it will get multiplied, but exponent sign will change, so it will become L raised power 1 upon 2, that is equal to under root L. So we will get here 3 under root L, 3 under root L divided by 2 under root K plus 3 under root L. Now the sum of n K plus n L will be equal to, let us add them up. So here we have 2 under root K, so we have 2 under root K upon 2 under root K plus 3 under root L, plus here we got this 3 under root L upon 2 under root K plus 3 under root L. Okay, here you can see we have the same denominator, we can add up the numerator. Okay, so we can write 2 under root K plus 3 under root L divided by 2 under root K plus 3 under root L. Okay, since numerator and denominator are same, we can cancel them, so the sum of output elasticity of capital and labor should be equal to 1. That means this option should be correct. I hope I make myself clear in this video. Thank you.